Hi everyone, and we are glad to welcome you again on our DevConnect session. And today's session is dedicated to Civil SDK. You're probably heard of this, familiar with this, or whatever. So today, during today's session, we'll introduce you the project, provide some key points, introduce you the recent updates that were being done, and after this, after the presentation part, we'll have a questions and answers session, and our development team, some of the developers of the Civil team are now online here, and we'll be glad to answer your questions. Now you can see the guys from our Civil team. Thus, just do not wait and ask your questions as soon as they appear, so we'll be able to prepare in advance and answer this during the Q&A session. So, okay, let's start with the introduction of the project. And first of all, we need to say that it's probably the oldest OD extension that we have, because the work on this project was started in July 2012. And as it was mentioned, it is an extension project, so that means that it is a vertical extension that is based on other ODE SDKs, drawings and architecture. Civil is based on top of this. So this SDK allows us to process Autodesk Civil 3D files in a standalone manner with no any additional tools, so software installed, only the ones from OD are enough, and it's possible to process different objects from those files for various engineering tasks, like planning, designing roads, railways, creating detailed terrain models, infrastructure design tasks, and like pipe networks, and so on. So, and if you need to use such objects like cargo points, thin surfaces, alignments, profiles, corridors, and that's all is possible with OD Civil SDK. And as mentioned, Civil SDK is an extension project. That means that the development priorities are formed by the Civil users community. So you have the opportunity to influence, to provide your feedback, to form the development priorities, and to work in tight connection with the Civil development team. So just another reminder that similar to all other projects, a free 60-day trial is also available for Civil, so you can evaluate its capabilities absolutely for free. And let's move on with the key points, and we start first of all with the data access. And when talking about the data access, we need to say about the following: that Civil SDK supports loading objects of versions from 2006 to 2025 and saves objects in the most recent Civil objects formats. So that means if you read the file of 2012, you'll be able to save it in the most recent 2025 only. And that works with Civil objects. And sorry, this one. And to work with this and to leverage the access of other capabilities, you have two options. You can use the native C++ API, or also the C# wrappers that are generated on top of the C++ are also available. So for some cases, it significantly facilitates the integration of ODE SDKs into .NET projects. Now let's move on further, and one more option to mention is the common data access. First, a small introduction that most likely you Also familiar with the common data access in OD, but just a reminder that it is an API that is used to access structural information and object properties of the imported models. And it provides a way to do it in a simplified and universal form. So it's quite important when you work, for instance, with multiple formats and need some unified procedure to access the data. So CDE support for Civil was introduced during the previous summit, and currently in the past year we continued our development of CDE for civil objects and extended the set of supported objects and properties. A couple of notes here. First of all, this feature is not enabled by default, and in order to use CDE, module AECC properties must be loaded manually or programmatically in the client application. The next point. This is a new feature, and coverage is not 100% of all the available properties due to the following. This work is in progress, but we need some help, feedback from the user side, because some civil objects have too many properties, and it may look just as an overkill to pass them all through the CDE. And it will be just excessive and strange in the UI. So we added it for the most important ones from our point of view and from the point of view of some members and their feedback. So just additional feedback here is very, very useful. So, but overall, this work is in progress currently, and we are agile. We will be glad to acquire feedback and to utilize it. We have a short demo illustrating this capability, so please couple some of your attention. Quite often CDE is used in visualize applications, and here you can see on the left side the tree structure, and on the right side the properties panel with the properties of the selected element, so that are available through the CDE mechanism. We can zoom in and pick another element. You can see the selection again on the tree structure and the changed set of properties on the property pane. So that's the idea. And now let's move on further. One more point to mention: bridges loading support. Loading support was implemented for classes of bridges model, and we plan to implement visualization support this year. Currently this task is in progress, but our data set is not again sufficient to introduce that as a production ready feature, but we hope that our membership community is also interested in these objects, and thus please send us some drawings so we'll be able to have a better testing base for our code. Move on further, and some words about the internal processing, because it's also important and influences the overall user experience. So first, let's start with some enhancements related to surfaces processing. A thin triangulated irregular network surface is a type. First of all, some words about the surfaces we work with. Is a type of digital representation used in civil engineering to model the surface of a terrain. It is constructed by connecting a set of irregularly spaced points with non-overlapping triangles. So the procedure, the thin surfaces creation stages, this step is important for understanding what internal implementation improvements were done. So first of all, data collection, gathering elevation data points through methods like land surface, LiDAR or photogrammetry. And next, triangulation, connecting the data points to form a network of triangles. This process can be done using various algorithms such as Delaunay triangulation. And the third step is the surface analysis, performing analysis such as elevation, slope, contour generation, etc. So these complemented logic worked well for small surfaces. We implemented this, but as you understand, as input data grows and surfaces become larger and larger, performance optimization becomes crucial. So that's more data, low performance is the pain that was shared by our membership community. And during the past year, we continued our efforts in the direction of improvements. And what we've done, we've implemented a new method for fast triangulation, graph traversal, and this allows fast insertion and triangle splitting. Currently, we can handle millions of points in seconds, which is much faster than we ever had. So that's one of the improvements. Next one, another key factor is topology correctness. And on topology, we fixed several issues. So first of all, a triangulation for break lines segments. Eliminated difference from Civil 3D because, as you understand, quite often nowadays the case I use to inject in workflows that use Autodesk products, and thus the smooth injection in those workflows is crucial. Next, incorrect surface boundary when appending new points, and surface elevation analysis, flat area filling, etc., and moved surface points exclusion after AEC surface depth move point application. So this was also one of the improvements. Next surface related enhancements is that also we implemented initial support of surface based definition, which allows to insert one surface to another. And topology insertion not only moves points, but also allows triangles from one surface to be embedded into another as is, preserving boundary stack and break lines. That's also important. The insertion area also prevents the surface from being validated. Currently, handling intersecting break lines and adding additional triangles in ambiguous cases is not supported. This feature will be added upon request. So we've got also a video to illustrate this. So as you see, that's the inserted one. Okay, so let's move on further, and the next improvement, it's the surface drape. So, and we are working on visualization support of draped thin surfaces. This feature allows displaying an image on the surface, for example a geo-referenced image, and to use this feature, switch to realistic mode and enable the display of triangles in the surface style components. The feature will be available soon, so for now it's not in the existing archives, but just follow the Civil release notes to get the recent update when it is available. So now we have a short video as well that illustrates this visualization. as it was mentioned, you need to switch to realistic mode, and that's, you can see how it looks like. Okay, let's move on further on, and another option, corridor to solid. Exporting a corridor to a solid in Autodesk Civil 3D is a useful feature for creating 3D models that can be used in non-civil applications or for visualization purposes. Again, you understand that sometimes it's necessary to have the possibility just to view, and it's difficult to guarantee that all the participants of some workflow will have all the necessary tools. So this process invokes converting the corridor, which is typically composed of multiple alignments, profiles, and assemblies, into a set of 3D solids and 3D bodies objects. So that's in some way some kind of simplification. So we have a video to illustrate this procedure. So you see that visually it looks the same. So if necessary, it's necessary to get some impression of how this element looks like, so there won't be any issues for getting the visual representation. Next item is that the export supports two output options are available for this. First, when the created bodies or solids are added in the DWG database, current database or another database with specified settings, and corridor related data in property sets. Second option is when raw geometry in terms of OD, it's OD model geometry pointer, is created. So we got also a video to illustrate these two export options. So here you can see that this is the first option, and you can see the property set window. So during export, the corridor is represented as a tree-like structure, so-called export context, and via the context, the users can exclude unnecessary elements, nodes from export, so thus customizing this. And since last summit we received feedback and got a request for this. So also setting colors, layers, naming templates is also available. So final elements and nodes in the context are links and shapes with various codes. By default, export sets color of shape or link from corridor. The name is code set, and layer name template is taken from settings of the command. Either the template can be changed and applied to all export solids or bodies, or color and layer names template can be specified individually for every element nodes. So next, let's move to visualize block, and as we understand, it's also an important part, and visualization is currently supported for the most of known objects, and civil entities appearance can be changed via styles, allowing to set up visibility, color, and other visual settings for every component of an entity. And quite many improvements were made in the visualization accuracy area, first of all. So we continued our work on alignment engine enhancements and implemented 2 alignment entities additionally, and improved accuracy of spirals and complex transitions. In addition to surface topology improvements, it positively reflected on many related objects besides the surface and alignment. As we mentioned that our development tasks and priorities are driven by our users community, we resolved quite many visualization issues that were raised by our members, and the list of entities for which we have improvements is the following. We did it for corridors, fixed render area fill materials for corridors with a self-intersection, scale of corridors, angular stations, for labels and tables, for super elevation views, for profile and section views, for profiles, and for pipe and pressure pipe networks. So there were some issues raised by our membership community, and we fixed a whole bunch of reported issues for this. The next block will be dedicated to creation. So we'll enumerate our creation capabilities. For now, we can provide creation support for Cogo points, for thin surfaces, for alignments, profiles, and profile views. The topic that is related to creation is editing, and we need to say about this as well. So editing is limited for a set of objects and properties for now. The relevant list of editing API can be found in our API reference in our documentation. The editing support is complicated because civil objects are tightly interconnected, sometimes implicitly. For example, changing alignment, profiles, profile views, projections, points, pipes, super elevations, cross sections, and corridors need to be updated. So due to this interconnection, updating each of the listed objects in its turn also leads to updates for related entities. So those interconnections introduce complexity. And one point that we need to mention, something about the future direction, our ideas and potential further directions, is the following. As you know, ODA supports both formats DGN and DWG, and we have import and export support for DGN to DWG, DWG to DGN. So this in turn discloses the possibility for open roads support, the Bentley open road support, and to export data from open roads to civil, or from civil to open roads. So it's necessary to decide, but for now we are searching the possibility to fund this project, and initially we plan, briefly speaking, to support as part of this project hydrology elements, additionally extract different civil objects from this, and visual data, of course. So these all will be implemented as part of this project. So if you are interested, just feel free to contact us, ask questions. We'll be glad to provide additional information and to cooperate with you. So briefly, I think that's it regarding the presentation part. Now we are able to start our questions and answers session. So please feel free to ask your questions. Just for now, as a common situation, this video will be placed on our YouTube channel. So if you wish to recommend it to somebody, you'll have it available, and it will be possible to view it later on. Of course, just one more reminder: in your emails you had the necessary information to set up individual meetings. So if you have some questions, issues that need a discussion, but you don't wish to do it in public, just use the information in the email to set up an individual meeting and to discuss it, say, face to face with our development team. So briefly, that's it. Of course, we'll be glad to answer your questions. If they appear later on, just contact us via the available channels. So, any questions? Okay, probably. Just also do not forget that next month we'll have another session, and that will be dedicated to publish toolkit, and we'll be glad to see you there as well. Okay, there were some questions regarding the video recording and etc., but we already answered them. Okay, looks no new questions appeared. Then okay, we say thank you all for visiting our DevConnect session. We'll be glad to see you. Hope to get your questions afterwards. And thank you and goodbye for today.